When most of us learned about the pH scale back in high school, we probably learned that it's a scale from 0 to 14, with everything below pH 7 being acidic and above pH 7 being basic. In reality, however, this is a great simplification of the concept of pH. If we measure the pH of water at 37 degrees Celsius, which is body temperature, we see that the pH is 6.8. And the first thought that comes to mind is, aha, this water is acidic because its pH is less than 7. But I can assure you that this water is neutral. After all, if heating up water made it more acidic, then drinking hot tea or coffee would be a very dangerous experience. To understand why this is true, we need to look at the equation for the autoionization of water. We know that water doesn't just exist as H2O liquid. It also self-ionizes to H3O plus and OH minus ions. From the stoichiometric coefficients, we see that when the water is pure, we always have equal concentrations of hydronium and hydroxide. Therefore, pure water is always neutral. To get from pH to H3O plus concentration, we use the familiar formula where the concentration of hydronium is equal to 10 to the negative pH. Thus, at 25 degrees Celsius, when the pH of pure water is 7, the concentration of hydronium is 10 to the negative 7 molar, and because of the 1-to-1 ratio of the stoichiometric coefficients, the concentration of hydroxide must be the same. At 37 degrees Celsius, the pH of pure water is 6.8, so the concentration of hydronium and hydroxide are both 10 to the negative 6.8. So how come the pH and ion concentrations change? That's because of Le Chatelier's principle, which states that temperature changes equilibrium concentrations. And because the concentrations of ions change, so does the pH. Now, what is so special about pH 7 that we call it the neutral pH? In reality, nothing. 25 degrees Celsius is just a common room temperature. And as it happens, the concentration of hydronium and hydroxide in pure water is 10 to the negative 7 at that temperature. And the pH is 7, which is a very nice whole number. So what does make a solution acidic or basic? As you have probably figured out, it is not the pH. In fact, only the relative concentrations of hydronium and hydroxide can tell us if a solution is acidic, basic, or neutral. When the concentration of hydronium is greater than that of hydroxide, the solution is acidic. When it is less, the solution is basic, and when the two are equal, the solution is neutral. Another misconception that you might have is that the formula pH plus pOH equals 14 is always true. While it is true that as you vary the pH at a constant temperature, the sum of the pH and the pOH will remain constant. However, it is not true that the constant is always 14. At 25 degrees Celsius, the concentration of ions in neutral water is 10 to the negative 7 for both hydronium and hydroxide. Thus, the pH and pOH are both 7. So when we add pH and pOH, we get 7 plus 7, which is 14. However, at 37 degrees Celsius, when the concentration of ions in neutral water is 10 to the negative 6.8, the pH and pOH are both 6.8. So when we add these pH and pOH values, we get 13.6. Thus, at 37 degrees Celsius, pH plus pOH is equal to 13.6, not 14. So the takeaway is that there is no single neutral pH. Any pH can be neutral at the right temperature. Because of that, we know that the equation pH plus pOH equals 14 is only true at 25 degrees Celsius. And the pH by itself cannot tell us if a solution is neutral, basic, or acidic. To tell, we must know the relative concentrations of hydronium and hydroxide.